Ladies and gentlemen, hello and welcome to another LeetCode coding question. Today we are solving question 143, reorder list. You are given the head of a singly linked list. The list can be represented as L of 0 to L sub 1 to L sub n minus 1 to L sub n. Reorder the list to be on the following form: L sub 0 to L sub n to L sub 1 to L sub n minus 1 to L sub 2, etc., etc. You may not modify the values in the list nodes, only nodes themselves may be changed. So what this question is asking us is simply to grab the end half of the list, reverse it, and then interdigitate the both lists together. So for example, in example 1, the end half of the input list is 3 and 4, and when we reverse it we will get 4 and 3, and then they want us to interdigitate those two, so 1, 4, 2, 3. Same with example 2, the end half of the list is 4 and 5. 4 and 5 reversed is 5, 4, so we have 1, 5, 2, 4, 3. So how we can solve this problem is we can just get the end half of the input list, reverse the end half, and then we can merge the first half and second half, or let's say interdigitate the first half and second half. If you've solved linked list questions before, you would pick up the pattern that getting the end half of the input list is a LeetCode question of itself, so is reverse the end half. I think these two questions are part of this month's daily LeetCode challenge. I remember doing a video on both those questions. So in this question, we are simply taking the solution from those questions and combining them to solve this problem. So getting the end half of the input list is a O of n solution, so is reversing the end half, and interdigitating the first half and second half is also O of n. So we can conclude that the runtime is O of n and the space is O of 1. We are not using any extra memory to solve this problem. So how we can solve this problem is written out. Now let's get to coding. So in order to get the end half of the input list, we need to use a fast and slow pointer. So we'll set both to head, and then while fast and fast.next, fast equals fast.next.next, slow equals slow.next. So our slow pointer now points at the second half of the input list. So our slow pointer is now pointing at 3. However, we want to cut the list off in the middle, and we can't do that from 3. As you can see, the arrow is a one-way arrow from 2 to 3. So we do not have a reference at the pointer 3. So we have to get our pointer to point at 2, so we can use the reference of the arrow and remove it or setting it to none. So how we can do that is updating our while statement to one step into the future by adding next to fast and fast.next, so we can gracefully end our pointer at 2 instead of 3. So with this updated code, our slow pointer now points at 2. Now we have that. Let's just set aside a extra variable. I'll call it OG slow, and we'll set it to slow. So we're gonna use this variable to remember the 2 that we found. And now we can move slow back to the 3. And now that we have slow back to the 3, we can reverse the end half. And we can do that by using the solution from the reverse linked list LeetCode problem. And how we can do that is using a previous variable. We'll set it to none, and then while slow, we will use a current variable to remember the current slow. We'll move slow forward, slow equals slow.next, and then we are going to reassign the current next reference to the previous node, which is none in the first iteration, and then we could reassign prev to current. And now our previous variable will point to 4, which is the head of the reverse linked list. And we have to cut off this reference, so we'll do ogslow.next equals none. So we just cut this off. Now we have 2 pointers that point to the head of both half of the list. I will show you what I mean. So we could print head and we could print prev, and if we did this right, head would point to 1 and 2 and prev will point to 4 and 3. So let's run our code and we can see. So head is 1 and 2 and prev is 4 and 3, as we expected. And now we can just interdigitate the 2 halves, and we can do that by using just 2 pointers, head1, head2 equals to head and prev, like we printed, and then while head2. So while, as long as we have a reversed half, we can continue with this code. So let's just set 2 variables to remember the head1 next and the head2 next before we start operating on them. So we're going to use these 2 variables to remember the references of the next nodes, and now we can start operating on them. So what we want to do is set head1.next to head2, and then we want to set head2.next back to head1 next, the reference that we saved. And then we want to, so head1.next will become head2. Head1.next will become head2. And then head2.next will become head1 next. Head2 next is 3. So we will reassign head2 to head2 next. And head1 needs to be changed back into 2, which is head2.next. And then we could return head. It got a little confusing right there. I'm actually a little confused myself. Let's check. Okay. Head1 next. None type has no attribute next. Let's double check our variables. Okay, our variables are right. Okay, let's go over this again. So while we have head2, we want to remember head1 next to head1. None type has no attribute next. Head1 became none, which is an issue. Don't want head1 to be none. Okay. Head 1 next. Okay, these two are right. We're just storing the variables, and then head 1.next will become head 2. Head 2.next will become head 1 next. Head 1.next. Head 1 points. Oh. Head 1.next will become head 2. Head 2.next will become head 1 next. And then head 2 has to become head 2 next. And then head 1 just needs to move forward. So head 1.next, head 2, head 2. Okay, so head 1 equals head 1.next. Okay. Okay, cool. Now we can just submit. There we go. Awesome. Thank you for tuning in for the LeetCode problem. This has been your daily dose of LeetCode. Goodbye and peace out.